One of the many useful benefits of hypervisors is the ability to provide high availability for applications that don't have their own redundancy solution. Now, in a small cluster, that typically involves using central storage like a NAS. But the problem is, if the NAS goes offline, so do your virtual machines. Fortunately, Proxmox VE supports ZFS, allowing us to take advantage of ZFS Replication. With this, you store your virtual machines on local storage and you replicate them to the local storage of another server. But how do you set up ZFS Replication in Proxmox VE and configure high availability for your virtual machines? Well, if that's something that you're interested in finding out, then stick around and watch this video, as that's what we'll be going over. Now, because this video is about ZFS replication and high availability, I'm going to assume you already have a Proxmox VE cluster set up. If not, then I do have another video which shows you how to create Proxmox VE clusters. In addition, if you only want to run 2 servers, I have another video which shows you how to set up a queue device which can save you money. Now, I've got a cluster here which involves 2 servers that are running my virtual machines. What you don't see is the queue device, which is providing that extra third vote so that the cluster can achieve quorum. But what we're interested in is setting up replication between server 1 and server 2 and vice versa. But to be able to use ZFS replication, you need ZFS storage. So to set that up, we're first going to go to server 1. Then underneath disks, we'll select ZFS. Then click Create ZFS. First thing we need to do is to provide a name. Now, I'm going to call this local ZFS, but you can change that, set it to whatever's more meaningful to you. To keep things as simple as possible, what I would suggest is setting up the same name on both servers when you're creating this storage. So I'm calling it local ZFS on server 1. When I set it up on server 2, it's also going to get called local ZFS. It is possible to have different names for your storage at a server level and a data center level. Again, I just want to keep things as simple as possible, so I'm not going to disable that option to add storage, but it is there if you want to. We then into the RAID level, which by default is single disk. Now, this server has 2 disks. They've both got the same capacity, so I'm interested in redundancy, so it makes sense to select both of these disks and change that to mirror. But as you can see, there's a lot of other options here, and it really comes down to the actual number of disks you've got more than anything and the type of redundancy that you want. We then got compression, which by default is set to on. Quite a few different algorithms to choose from. There's even an option to disable that if you like. What on means is LZ4 basically, or at least at the time of recording. If you check the documentation, that's what it's going to be using. So that's good for compression, but it's also good for performance. So I'm going to leave that set up on. The only other option we've got is A shift, which by default is set to 12. Now, unless you really know what you're doing, it's best to leave that as is, because like the documentation warns, you could end up degrading the performance. So that's all I need to do to set this up. So I'm then going to click on Create, and off it goes and sets that up. Now, I need to set up the equivalent on server 2, so I'll select that. Again, under disks, click ZFS, click Create ZFS. I need to give it the same name, because again, I want to keep things as simple as possible. Now, just to demonstrate, I'm actually going to pick only 1 disk for this server, and I'm going to leave the RAID level set to single disk. Compression, A shift, again, I'm not going to touch either. I'm not going to change add storage either. The reason I'm doing that is just to demonstrate you don't necessarily have to have redundancy and multiple disks to be able to use ZFS, so, which is good for a lab, but also depending on your budget. I mean, I put out a community post where I was showing some of the hardware that I've been purchasing. There's only 2 disks involved. These are enterprise grade SSDs, which is the recommendation. They can handle a lot more writes than your typical retail SSD. So I purchased 1 for each server purely down to budgeting reasons. But the idea is I can actually do that with ZFS. The goal is that once I've got some more money, I'll actually purchase some more disks, and then I'll set up the redundancy. So I'll be able to basically tear these pools down and then create new ones with actual mirrored disks. So like I say, it is possible. You're not restricted and you're not forced into having to have multiple disks to be able to take advantage of this. In any case, all of those options are picked, so we'll click on Create. Off it goes and does the equivalent for server 2, so it's just got to wait for that to finish off. But one thing I'll point out is that yeah, we've got local ZFS reference there, local ZFS reference there. But if you go to the data center level, if you go to storage, we've now got local ZFS. Now, if you click on edit for that, you can see that it's only given us choices for disk images and containers, because really it's all about replicating virtual machines and containers between ZFS pools. But you can also see the actual nodes involved, options for thin provisioning as well. But in any case, we've now got our actual ZFS storage configured. Now, just like a physical computer, a virtual machine will have one or more hard drives. Except in the virtual world, a hard drive is basically just a file. Now, in order to run a virtual machine, a hypervisor will need access to those actual files. So if you're just setting up a new virtual machine, what you can actually do as part of the build process is to define your ZFS pool to be where the actual hard drive is actually being stored. But if you've got existing virtual machines, like I have here, you want to actually migrate the hard drives to the ZFS pool, and then you'll be able to replicate them afterwards. So if we pick out virtual machine VM test here, and then go to hardware, its hard drive is in a storage location called VMs. So in other words, this is actually on a NAS that I've got. I'm connecting to that NAS through NFS. But if I want to set up ZFS replication for this virtual machine from this server to this server, I need to actually migrate that hard drive. So to do that, I'm going to select the hard drive, select disk action, and then select move storage. It then asks me what the target storage is. So I'm going to click on the drop down menu, and I'm going to point it to local ZFS, because that's where we want it to go. One thing to point out with this is I can't set the format here. The only option is raw. On the actual NAS, it could be QCOW or raw. In this particular case, that's my only choice. What I do like to do is to select that option, delete source, because I don't want to keep redundant copies, if you will, on the original location. I just want to move the actual hard drive off of the NAS onto local storage. So I'm selecting that option, and then we'll click move disk. And now I've just got to wait for the actual file to be moved over from the NAS to the new ZFS pool. Now, although we've got two servers here, each have got local ZFS storage, and it's called local ZFS. The hard drive for our virtual machine here, which we've migrated across from the NAS, is only being kept on server 1. And I can tell that because if I click on local ZFS here, then go to VM disks, well, there's the file for its hard drive. If I go to server 2, on the other hand, the file isn't there. And that's because we need to set up replication of this virtual machine over to this server. So there are different ways you can do that. I mean, go to a data center level. There's a replication section there, so we could set up replication jobs here. We can do it at a server level. So replication's right the way down there. Again, we can set up replication jobs here. The only trouble is, what I found is you can't set up replication for multiple virtual machines at the same time. In addition, you've actually got to enter the virtual machine ID at either of these two levels. In which case, for me, it's easier to just set this up at the actual virtual machine level. So this virtual machine now has its hard drive in the actual local ZFS storage. So what we can do is set up replication by clicking on the replication tab, then clicking on add. So it's automatically picked out what the ID is. It's now giving us a choice for targets. Well, there's only two servers in the cluster. The virtual machine's on server 1, so not surprisingly, all I can do is replicate to server number 2 here anyway. Then what you could do is to set up a schedule. Now, it's not going to replicate every time data changes on the hard drive. It's not that sophisticated. You've got to set up an interval of time to actually replicate on. So by default, it's going to replicate every 15 minutes. Now, to me, that's still better than the potential of restoring from backup, which could have been done 24 hours ago. And it still seems better than the potential of your NAS going offline and taking everything with it anyway. But for the sake of the actual video here, I'm going to actually reduce this to 1 minute by just typing in */1, just so that it gets done quicker, because otherwise I'll have to wait roughly 15 minutes, then it'll start replicating. And then once it's replicated, it'll keep replicating at that interval afterwards. One thing to bear in mind though is that a lot depends on the amount of bandwidth you've got, whether you've got a dedicated interface to be able to do this sort of thing. Because although, I mean, the initial replication will be the entire drive, after that it'll be deltas, it still could potentially be quite a bit of data getting replicated from one server to another. So that's something you've got to think about. If you do this too frequently, yes, you'll be losing less data, but on the other hand, that's a lot of data potentially, especially if you've got quite a lot of machines that you're trying to set this up for, being copied across over, between your servers, and it could take up quite a bit of the bandwidth on the interface. I mean, there is an option down here where you can actually rate limit the amount of bandwidth that can be used. The only thing is you've got to time that with the interval. You've got to be able to have enough bandwidth to be able to replicate the data across within that window of time before the next replication job gets done. So you can have a bit of a play around with these and practice these, because there's quite a few to choose from. Like I said, if you don't do anything, the default is every 15 minutes, but for the sake of the video, I'm just going to do every one just to get the work done quicker. And then if you want, you can put in a comment. Now, by default, the job is enabled, but you can disable it either now and arrange it for, say, like out of hours, for example. I mean, there is opportunities here where you can set it up to be run at a specific time of the day, but the whole idea is the longer the gap between each replication, the more data you're going to lose. I mean, this to me doesn't seem to be something you'd be using for critical data anyway. I mean, things like databases, for example, make more sense where they've got their own replication model. You replicate it from one database server to another every time there's a change. Your typical infrastructure servers, it's not that big of a deal if you lose, say, 15 minutes, because you're talking probably about just logs, for example. You lose a few log entries in that short space of time. But again, it's entirely up to you what sort of settings you put in. You'll have to experiment yourself to find out. But here, we're going to do it every 1 minute. So we're going to click create, and then that sets up the job. Now, it doesn't kick off straight away because it's timing it for the next sync. But once you've got the job set up, you can maintain this at a server level or a data center level. So if I go up to the server, you can see there's the job there. If we go up to the data center, there's the actual job there. So you can probably find it easier to set up the actual replication itself at the virtual machine level. And then it's up to you whether you want to maintain it at a server level or a data center level, probably. Well, our replication is working as intended, because if you go across to server 2, then to its ZFS pool here, there's a copy of the hard drive. Now, the only trouble is that's not enough for the redundancy that we need. Because if I go to the virtual machine, there's all sorts of other information, how much memory it's got, how many processors that it's got, and so on. And that isn't stored in the hard drive. Yet that's the only thing we're replicating from this server to that server. Fortunately, we actually want to set up high availability anyway. Reason being is we want automation and we want to minimize the downtime, and that takes care of all of this. So we're going to go to data center, expand out HA, click on groups because we want to set up a new group, click on create. Now you can call these whatever you like, but I'm going to call this one Prefer Node 1. The idea is this is going to be for virtual machines that I prefer to be running on Node 1, or this case server 1, PVE demo 1. I'll select both servers because they're the only servers in the cluster, and I need 2 at least for redundancy. Server 1 is preferred, so I'll give it a higher priority of 10 versus 1. Restricted won't apply to me, but if you've got a lot of servers in a cluster, that could be useful under certain circumstances where you only want your virtual machines to be running on those servers that you've defined within the group, for instance. No failback. I do prefer to have this option always enabled. The reason being is that I do actually prefer the stability over the automation. So without that option, let's say server 1 goes offline. HA kicks in after a while, and then it spins up those virtual machines on server 2. Once server 1's back online, you'll get these virtual machines being migrated back to server 1 automatically. The only trouble is if that server just keeps resetting for whatever reason, you're going to end up with your virtual machines going up and down all the time, which isn't stable at all. So that's why I prefer to just set that option so that once the virtual machines are up and running on here, they'll stay there. I'll have to manually migrate them back. And that's actually very, very easy to do now because we've got a bulk migration option. You can give your VMs tags, which includes a tag to say what actual server they belong on. So it's very, very simple to manually migrate lots of virtual machines in one go. So those are the sort of settings I prefer. So I'll click on Create. Now we're only setting this up for one virtual machine, so I'm just going to create that one group. But we need an actual HA rule for this to all work. So click on HA, click Add. We'll pick out our virtual machine because it's the only one I've got set up with replication anyway. We'll pick out the group. Now, when it comes to the request state, normally it's set to started, which is what you want. You actually want the VM running. But there are other options. I mean, ignored's actually quite useful for maintenance, but in this case, I'm just going to leave it started because that's what I want. We then got 2 other options. One is max restart, and another one's max relocate. So max restart is how many times to basically try to restart a virtual machine if it actually goes offline. And I've had situations where a virtual machine just suddenly shuts down for no apparent reason, potentially a software problem, and it's just caused it to go offline. Well, this is how many attempts will be made to get it back up and running. Default is 1. We can set this to higher if you like. We then got max relocate. Now that's to do with migrating it from one actual server to another. Again, that's set to 1. Now, I don't know if this necessarily applies to Proxmox VE. I haven't seen anything in the documentation, but back in my VMware days, typically you might set something like that with a max restart of 3. The idea being to give the virtual machine enough times to actually try and restart on a server. Sometimes there might be just strange things, and the actual virtual machine goes offline, and for whatever reason, after 3 attempts, it does actually work. The only catch is if you then run into a situation where server 1 goes offline, the actual HA would actually attempt to actually get that virtual machine up and running, in this case 3 times on a server which is actually out of service, so that just wastes time. So like I say, I haven't seen anything specific in the documentation to say whether it ignores a server that's down or not, but in this case I'm just going to leave it set at the default of 1 for both. But you might want to experiment on those because some virtual machines have strange behaviors, shall we say. It has been seen. You can also put in a comment here if you like, particularly if you want to put in a bit more detail than just knowing that this is virtual machine 100, for example. So I'm going to call this one test, and I'm going to click on Add. But I mean, this applies specifically for that one virtual machine, where we're basically setting up HA specifically for that. And like I say, if you look at that, VM100 straight away doesn't mean that much. So that little description there could be quite useful for you. So we waited for HA to kick in, and now there it is. It's saying has started. So it's basically all ready to go. It's providing protection for that one specific virtual machine in case either the virtual machine goes offline or the actual server goes offline. Now in theory, we've got our redundancy in place. We're running replication to copy the hard drive of this virtual machine from server 1 to server 2. We've also got high availability set up to cover against server 1 going offline. But as ever, it pays to actually test this all. So over here, I'm actually connecting to server 2, and we're on the console of this virtual machine here, and it's running a constant ping test across to our virtual machine here that we've got covered. So what I'm going to do is basically just cause an outage effectively for that server to take it offline. So the idea is we then should see our HA kick in, and then we'll pick up with wherever the replication left off. So, oh, there you go. We've lost access to server 1. If you go to there, as far as it's concerned, server 1 can't be accessed either. So it looks like the pings have now stopped. There, we're now starting to see the problems occur because our virtual machine is no longer accessible. So we've basically just got to wait now for high availability to kick in. Well, there you go. There's our virtual machine now up and running on server 2. So it didn't take too long for it to notice that the original master server had gone offline, and now server 2 has taken over. And then you had to wait a short while to get a lock, and then it's actually started the virtual machine back up on the actual server. So there's only like a few minutes between detecting the server went offline, roughly 3. I mean, I was having a look, and that's around about the time the server was disabled, just shortly before that. And then you're looking at about roughly 3 minutes, which is not bad actually, especially as I say when you compare it to something like having to restore from a backup, or coming in the next morning and suddenly finding nothing's working. That's pretty quick. I mean, if you want something better than that, you're looking into dedicated appliances. I mean, I'm talking about, say, like firewalls, for example, where you have a primary and a secondary, and they can actually detect fairly within milliseconds. They are very, very quick to actually recover from a node going down. So even something like this, though, it's still pretty good. So it's not something, as I say, I'd be using for like very critical data in a database, but for your typical application infrastructure server, it is very, very useful, I'd say. So now that's up and running, we'll just double check. So if I go over to server to virtual machine 2, our ping should be back up and running again. Yeah, so it's just because that's all it's doing. It's just running a ping from that virtual machine to that machine. So you did see that brief, loss of connectivity for a few minutes. But what it means is that whatever data was on that virtual machine here was lost, depending on how long that window interval was, because we're running a replication job. At this moment, it's running every minute, which I'd say isn't really practical. Maybe 15 minutes, maybe longer, it depends. But that's not too bad. Now, one thing I'll point out is that if we go back to data center, if we go over to replication, you can see how the target here, we edit the job, the target has actually changed to server 1. So it's doing all this without me having to do anything else. As far as it's concerned, the virtual machine's now migrated across from server 1 to server 2. The replication job's actually been updated. So now what it's going to do, it's going to now replicate the hard drive from server 2 over to server 1. So it really makes sense for me to bring that server back online again. But that's what would happen normally. So it's very, very useful in that sense. It's not a case of we've replicated the hard drive from server 1 to server 2, and now we've got to go back and start fixing the actual replication job as well. That's all taken care of. I mean, if we go to HA, at the moment it's sitting on server number 2. Now, because I've got that set to no failback within the group, just go down there to there, edit that. This is not going to automatically fail back once that server's back up and running. I'm going to have to manually move it back again. So that server looks to be more or less back up and running. It just needs to sync itself back up again. So it's hooking back into the NAS over there. And we should start to see, I mean, this hard drive on here will be out of date for a short while, but then the actual replication job should kick in. If we go to the replication job on the server, from the server's perspective, it's just sitting there, it's waiting for issues because of the fact that it couldn't probably talk to the server. So what I need to do is probably just wait, let it resync back to that server, and then it'll get things back in sync again. But then I'll actually migrate the actual virtual machine back to that server once it's done. I mean, if you go back to the data center level, if we go to replication, we're not getting those details about when it last synced. You've got to go down to the server level to get that sort of information. So it's in the middle of actually doing that now. I mean, if I go to server 1, incidentally, there is no job. I mean, this whole automated process is taken care of, so it's essentially just moved the replication from one server to the other. So that's extremely useful that it's done that. So yeah, we've now synced. So now that it's done that, I'm actually going to go back to this virtual machine because as far as I'm concerned, it belongs over on server 1. So what I'm going to do is to pick the actual virtual machine here, tell it to migrate that across to the actual target node. Now, as it says, it's going to take a while because we're migrating the actual virtual machine from this server to this server. I mean, it's not like when I was migrating the actual hard drive. That doesn't apply here. We need to move the actual virtual machine as a whole, and it should take its drive with it. So what we'll do is we'll just pick that, click on migrate. So we're not migrating the hard drive, we're migrating the entire virtual machine. Click on migrate. And then now I've just got to wait for it to move back to the original server. Okay, so that looks as though it's actually done because we're now seeing the virtual machine over here on server 1. We've got a little green play button. So we're going to check our virtual machine here. Go and check its console just to make sure things are working okay. So yeah, so we're still running our ping tests. So if you now go to server 1, if you look at its replication task, so it's now got replication and its replication is back over to server 2. If you go to server 2, there's no replication to be done because the virtual machine now exists over here. I mean, it does still have a copy of the drive. It's just really now being synced from server 1 to server 2. It's just going to keep running that. I mean, it's saying it's taking about 12.5 seconds to replicate that. So it's mainly because it's replicating deltas. But yeah, it's setting up that HA takes care of this whole issue of not having the virtual machine information, because otherwise you'd have this problem where you'd have to manually do it, shall we say. You'd have to set up like an equivalent virtual machine over here with all the actual information and then attach the hard drive in, if you will. But by setting it up this way, the whole thing is automated. In an ideal world, we'd all like to have a hyperconverged solution such as Ceph, but I don't run enough VMs to justify the extra servers that would be needed. I still want a cluster, but I use a queue device rather than a third server, as that to me would be a waste of money. In the case of Ceph, you need at least 3 servers to get it up and running, but it's recommended you have a minimum of 4. During normal operations though, you should have an odd number of servers in a cluster, which means you really should have 5 servers. Now, I can run all of my VMs on one server, so I only have 1 extra server because I want the redundancy. But adding another 3 just so that I could have Ceph wouldn't make any sense at all. In which case, ZFS Replication offers a very useful way to deal with that single point of failure that is shared storage. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourselves that are watching. in which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.